Section 6 of Chapter 4, we're going to learn something that is going to make you a little frustrated at me, just a little bit. It's something you've learned in the past. It's called the quadratic formula. We've gone over factoring, we've gone over solving quadratics using a variety of different techniques, GCF, area model, completing the square. Some of them are good, some of them are bad, some of them they work sometimes, some of them they don't work at all at a lot of intervals. The quadratic formula is a technique that is always, always, always going to work. It never misses. Even when you're trying to find solutions that don't exist in the real number space, it actually still works, and we'll get into that later. The reason why I wanted to save this for the very end is because typically I found in the past, if I teach students the quadratic formula at the very beginning, they get a false sense that this chapter is really hard, and they just lean on this way too much, and they try not to learn the other concepts because this always works. Additionally, I don't like teaching this at the very beginning because it's as if I just pull it out of a hat and I say, look, this works because I'm a math teacher and I say so. I want to show you where it comes from, but in order for us to do that, we had to develop the rest of the chapter previously. All right. Before I show you the quadratic formula and how it works, I want to review kind of like a recap of what we've done this chapter. This is just going to be very, very brief. I'm going to go through it really quickly. I'm not even going to work through the problem. I'm just going to show you the steps. I have two problems, y equals x squared plus 2x minus 3, and y equals 4x squared plus 16x plus 7. If I wanted to find where those two functions, those two quadratics hit the x-axis, the very, very first step I would do is set them both equal to 0. Change the y to 0, because if you're trying to find where a function hits the the x-axis, the heights are 0. The y values become 0. So first step, set y equal to 0. Then we have a quadratic, so we would factor it. You could use whatever factoring technique you want. I've primarily been focusing on the area model so that I could prep you for completing the square, but use whatever technique you want from here on out. Once you have it factored, you would then set each one of those factors equal to 0. So I'd set the x plus 3 equal to 0, the x minus 1 equal to 0. For the red one, the blue one, I'd set the 2x plus 1 equal to 0 and the 2x minus 7 equal to 0. We'd solve each one of those and get our x-intercepts. For the red one, the x-intercepts would be negative 3 and positive 1, which is why if you graphed it, it would look like this. And the x-intercepts would be at negative 3 and positive 1. So this algebraic process allowed us a brief glimpse into an element of graphing quadratics, namely finding the x-intercepts. The blue equation, those were fractions. This is really nice because if you just tried to graph it right at the onset, you would get this. And it would hit at a fraction. And we wouldn't be able to specifically say, does it hit at negative 1/2 or negative 1/3 just by looking. This is an algebraic process for us to verify. It hits at negative 1/2. It hits at negative 3.5 or negative 7/2. This is what we just got done doing. This works. This is fine. I am going to show you a new technique that'll get the same answers. But the benefit is it will always get the right answer every single time. Factoring sometimes doesn't work, or sometimes it's a pain in the butt. So this other way to find x-intercepts, as I've already said, is called the quadratic formula. I'm putting it really big and bold because it is incredibly, incredibly important. I would say all of you need to memorize this. Finding x-intercepts is a big element in mathematics and the science classes that are based on it, mainly physics. All right, quadratic formula. Let's do this. If you are given a quadratic function of the form 0 equals ax squared plus bx plus c, where a, b, and c are just some arbitrary numbers. They could be fractions, decimals, integers, positives, negatives, doesn't matter. They're just numbers. So you're given a quadratic equation, meaning x is to the power of 2, and that's the highest power of x in the equation. You'll have values a, b, and c. You'll be able to calculate the x-intercepts with the following. then the x-intercepts are negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times your a value. That's the formula that you all need to have memorized. So this is our quadratic formula. It is wrong color. It is incredibly important to mathematics going forward. This shows up a decent amount. Now, if you take a further glance at it, you might notice a part of it looks familiar. The part underneath the square root, the b squared minus 4ac, that was the discriminant that I told you I would show you where it comes from. It comes from the quadratic formula. If you remember back to when we were discussing the discriminant, I said if the discriminant was a negative number, we'd say there's no real solutions. If it was 0, we'd say there's 1 solution. And if it was positive, we'd say there's 2 solutions. Look at how it plays into the quadratic formula. If the discriminant is negative, you'd have to square root a negative. Hence why there would be no real solutions. You can't square root a negative. If the discriminant is 0, the square root of 0 is 0. And then remember, this is just going to be a number. So negative b plus or minus 0 would just be negative b. So instead of the plus or minus creating 2 numbers, it only creates 1. Because you're adding and subtracting nothing, which means you get the same number twice. That's why if the discriminant is 0, there's only 1 solution. And then lastly, if this number is positive, then it'll have a positive answer. And if you add and subtract a positive number, you're going to get 2 different numbers. That's why there are 2 solutions. Again, right now, it looks like I just came up with this out of the ether. I will show you where this comes from later. Now, this is the problem I did on the very first page, except there's a small typo when I wrote it. This is supposed to be a negative 3. Oh, and then that means the graph is in the wrong location. There you go, I fixed it. So the x-intercepts by factoring I found were negative 3 and positive 1. That's fine, that's correct. I want to show you how I could also generate the same answers using the quadratic formula. So I have the equation y is equal to x squared plus 2x minus 3. Your a value is the number in front of the x squared, which in this case is a 1. We just don't write it. The b value is the number next to the x. The c value is the number at the very end with no variables. It includes the negative with it. So therefore, our formula is going to give us x is equal to negative b plus or minus a square root of b squared minus 4 times a times c, all divided by 2 times my a value. The benefit of using the quadratic formula is it always works. The downside is, well, we're going to have to calculate that. It involves squaring, multiplication, subtraction, negatives, a plus or minus, a square root, division. It involves a bunch of different mathematical operations. All it takes is for you to mess up on one of those things and you will get a completely wrong answer. So the benefit is, always works. Downside is, that's kind of annoying to calculate by hand. Luckily, y'all got calculators. All right, so let's do this. This is going to be equal to negative 2 plus or minus the square root of 2 squared is 4. Negative 4 times positive 1 times negative 3 is positive 12. And that'll all be over 2. That'll equal negative 2 plus or minus the square root of 4 plus 12 is 16. Hey, that's a square rootable number. That's nice. That'll be equal to negative 2 plus or minus the square root of 16 is 4 all over 2. Once you get to this step and you do the square root, this is where it'll branch into 2 different equations. One's going to be negative 2 plus 4 all over 2. The other one's going to be negative 2 minus 4 all over 2. So one of them we use the plus sign, the other one you use the minus in the plus or minus. Negative 2 plus 4 is 2. 2 divided by 2 is 1. There's one of my answers. Hey, what do you know? It matches with one of the answers we got. The other one, negative 2 minus 4 is negative 6. Negative 6 divided by 2 is negative 3. What do you know? That's the other answer we got. -1, -3. So this is just another technique. However, I highly recommend that you memorize this one because it's the only technique I've provided besides completing the square that always works. This is the second problem that I did on the very first slide with information on it. I already have the answers of -1/2 and -7/2. Notice the answers are fractions. The quadratic formula can also find fractional answers. Once again, the equation is y equals 4x squared plus 16x plus 7. So my a value is the 4, my b value is the positive 16, and my c value is positive 7. Therefore, according to the quadratic formula, x is going to be equal to negative, the b value is 16, plus or minus the square root of the b value, which is 16 squared, minus 4 times the a value of 4 times the c value of 7. All of this is divided by 2 times the a value of 4. Now, here's the annoying part about the quadratic formula. These are not actually that big of numbers, but as you can probably tell by looking at it, they're going to produce some rather large numbers. Highly recommend if you're going to use the quadratic formula, have a calculator handy, unless you want to figure out what 16 squared is off the top of your head. I don't know what it is off the top of my head, but luckily I cheat. I have a key at the top of this page. -16 plus or minus the square root of 16 squared is 256. Minus 4 times 4 times 7, it's 112. All divided by 2 times 4 is 8. That's going to be equal to -16 plus or minus the square root of 144. All over 8, which is equal to -16 plus or minus the square root of 144 is 12. All over 8. This is where it splits. It's going to be -16 plus 12 all over 8, and -16 minus 12 all over 8. -16 plus 12 is -4. -16 minus 12 is -28. Both of those are reducible fractions. They're both divisible by 4 for the first one, and they're both divisible by 4 for the second one. And that is equal to -1/2, -7/2. Those would be my solutions. Before I leave you off, I want to remind you of a couple things that I would like that's going to help you. First, if the discriminant is negative, meaning this is going to produce a negative number, you get to this step and it's a negative underneath the square root, you stop and just say no real solutions. Additionally, if you get to this step right here, where you're going to be square rooting this number, if this number is not square rootable, you're done. Put a box around it. It's going to give you a decimal answer. Decimals are rounded answers. This is a precise answer. You only go from this step to the next step if the number underneath the radical is square rootable. Later on, we'll go over simplifying radicals a little bit more easily, but for right now, if it's not a perfect square, don't go on.